So, yes, we're going to talk about PFAS in cosmetics, and we're also going to talk about thinking about whole classes or families of chemicals. We're the Green Science Policy Institute. We do research, we're scientists, we collaborate with business, government, nonprofits, academics, and we communicate. And doing all these things, we're able to change policy and, even more important, purchasing of manufacturers and retailers to move away from harmful classes of chemicals. We have come up with the idea that there are 6 major classes or families that contain the majority of the harmful chemicals in everyday products. If any of you have time, you can go to sixclasses.org, and in 4 minutes you can see a video about each of these 6 classes, where they're used, why they're harmful, and what you can do to reduce exposure. Today we're going to be talking about the first class, which is PFAS, and I always like to say they're my favorite class because they're the very worst and the very best. So they are quite useful. And the reason they're the worst and the best is there's a very strong bond between carbon and fluorine. It's been said it takes the energy of lightning to break that bond. And that means that once you make a PFAS, it's there forever. It never breaks down in the environment. And most of the PFAS, all the PFAS that have been well studied, have been found to be harmful. So creating a chemical that never breaks down and is harmful is a big responsibility, and we don't want to do that. They do provide oil and water repellency. They're useful in some industrial processes, but basically we don't want to use them. They are used. They used to be used in carpets. They aren't anymore, but in food packaging, furnishings, as we'll discuss, cosmetics, outdoor gear, firefighting foam is a big problem. Tens of millions of Americans have had their drinking water contaminated by PFAS. And if any of you don't know if anyone's seen the film Dark Waters, it's a great film about an attorney, Rob Bilott, portrayed by Mark Ruffalo, who discovers a huge contamination from a DuPont factory in West Virginia. Anyway, I really recommend the film. It came out right before the pandemic, so it didn't get the attention it might have deserved, but you can get a good feeling for PFAS from watching Dark Waters. Unfortunately, PFAS to some level are in virtually all of us, and exposure has been linked to 2 kinds of cancer, high cholesterol, obesity, a whole host of health problems. So we don't want PFAS in our products, in our environment, or in us. There used to be a PFAS on the left called C8, 8 carbons surrounded by fluorines. PFAS it's a chain of carbon all surrounded by fluorines with these strong carbon-fluorine bonds. The C8 molecule, it was known as early as the 1960s that it was quite harmful. The chemical industry did not share that information, but because of the molecule's extreme persistence, the fact that it accumulates in living organisms, and it's toxic, in 2015, 50 years after the toxicity was first discovered, the manufacture of C8 was stopped, but the replacement was C6, 6 carbons surrounded by fluorines, which also is similarly persistent, can bioaccumulate in plants, and we're learning more and more about the toxicity. And because C6 is 6 carbons, it's smaller and it moves faster, and it's actually harder to clean up. And C6 is what is used in a lot of cosmetics, unfortunately. So PFAS are problematic, really difficult to clean up, and it's much more preferable to prevent their use. And that's why we're here today, to talk about preventing their use in cosmetics. And I'm going to start with some optimistic stories from our institute. About 2016, we discovered that PFAS was used in fast food packaging, so the oil and grease would not go through. And we wrote a paper finding that about half the fast food packaging, we tested several hundred samples, had fluorine, which meant it very likely contained PFAS. We communicated it through a lot of media. Senator Blumenthal from Connecticut wrote letters in 2017 to Burger King, McDonald's, and Wendy's, warning them of the PFAS in their wrappers and asking them to do something about it. And we later learned that when this happened, the major fast food brands all realized that they would have to stop using PFAS, and they started looking for alternatives that were functional and affordable. We heard, for example, that McDonald's was able to replace PFAS quickly, rapidly in most of their stores, but it took till a few months ago when they announced it was out of all their packaging worldwide. Similarly, Wendy's has announced it, and a number of other fast food chains. So once people know that PFAS is present, they can really stop the use. And another good story is Keen Water Shoes decided they wanted to remove all PFAS, and they looked through their shoes and they found it in 101 places. Their different lines of shoes, and they checked, was it performing a useful function? And 70 of the PFAS uses were not necessary, and Keen was able to remove them right away. But then it took them 7 years of work and quite a lot of money to find replacements for the other 31 uses. We think in cosmetics, since they're only in a small number of the brands or of uses, that they're not essential. And if they're not essential, then they can be removed a lot more easily. So going now to our paper, and I will say that Heather Whitehead, who's the first author of this paper, is here joining our call. Welcome, Heather. And she's going to be available to answer your specific questions about the research. But Heather and other scientists looked at about 230 PFAS, 230 cosmetic products, and found some PFAS in about half of them. And PFAS that is in eye products can directly go through our tear ducts into us. It can be inhaled if it's volatile, and then it can be eaten if it's in lipstick. Additionally, something we don't think about so much, but if we think about the products, eventually they get disposed of or washed down the drain, and they end up in landfills. And the PFAS, remember, is forever, so it can leach out, end up back in our water supply or in our food, and then we get the PFAS back from our food and water. So PFAS is better not ever used. Once it's out in the world, it is forever. So in Heather's study, she looked exactly at 231 cosmetics, 52% had high fluorine, which meant they very likely had PFAS. The highest level was in waterproof mascara. 82% of the waterproof mascaras contained it. So if you have waterproof mascara in your brand of cosmetics, that would be a good place to look. The second highest was in foundations, and the third was in liquid lipsticks. So those are products that would have quite a bit, but all lip products had 55%, and all mascara had 47%. So why are there PFAS in cosmetics? Well, they can increase the durability, the spreadability, and the skin absorption. You don't want skin absorption if it's PFAS, but they can increase that. And they can improve the skin appearance or texture. But as I said, we're quite concerned about absorption through the skin, eating it, going in through the eyes, and then we're concerned when it's disposed of down the drain and ends up in a landfill and can come back in our food and our water. So are PFAS in cosmetics regulated? And the answer is no. The existing FDA regulation does not specify testing requirements for safety of cosmetic ingredients. Due to some regulatory problems, PFAS are not even listed as hazardous substances, so they certainly are. And there are a lot of loopholes in labeling, so you can have PFAS in your product without it being labeled. I forgot to say that most of the PFAS products containing PFAS in this study, I think 89%, most of the products containing fluorine in the study were not labeled. So there have been 3 previous studies of PFAS in cosmetics in Europe, Japan, and Korea. And they looked at foundations, face creams, concealers, sunscreens, and shaving foams. And they found PFAS in many products, but they actually only tested products where PFAS was disclosed on the label. I know we looked at labeling of PFAS products. A summer intern about 5 years ago looked and found about half the products she looked at did have PFAS in words that meant there was likely to be PFAS in the labels. Now they're relatively few. We hope that means that there's less PFAS, but it could be that the labeling is obscure, as we'll discuss further. So we actually were not testing directly for PFAS in most cases. We were doing a rapid screening test for high fluorine, and that meant it was likely PFAS was present. And it was most common in products that were long-lasting or wear-resistant. Out of the 231 cosmetics, we looked at 29 samples in detail. Marta Vanier at Indiana University measured for individual PFAS. And in those 29 samples, all were found to contain at least 4 different PFAS, and only one of them was disclosed on the label. There's a C6, that's 6 carbons surrounded by fluorine PFAS, that was found in 28 of the 29 samples, and this same PFAS had been found by the FDA to be unsafe when used in food packaging. So it's a PFAS of concern. So the 29 samples, we can ask Heather about it afterwards. I believe they were ones with some of the higher levels. So our paper went online June 15th. Some of you may have heard of it. We had worked with colleagues in the Senate and the House. So the same day, June 15th, the Senate No PFAS in Cosmetics Act was introduced by Susan Collins from Maine, Richard Blumenthal from Connecticut, and 5 other senators. This legislation would direct the FDA to ban the intentional addition of PFAS in cosmetics. 2 days later, the House introduced an identical No PFAS in cosmetics with the same wording. It also was bipartisan, led by Debbie Dingell, Brian Fitzpatrick, Annie Kester, and John Cato, 2 Democrats and 2 Republicans. And many bills are introduced that don't come to fruition or not pass. That's kind of what usually happens. But bills that are bipartisan and the identical wording in the House and Senate have a relatively good chance of moving forward. We hope you will support this legislation. Also, on the 17th of June, the Senate Personal Care Products Safety Act was introduced, and that's a much broader and more wide-ranging bill asking for transparency in the supply chain and a number of really important provisions. So these are all good things to support. So the question you're all wondering now, what can cosmetics brands do to ensure their products are PFAS-free and happy, like these girls are, women? Avoid all unintentional use of PFAS or PFAS in disguise, which we'll talk about later. Test your products for PFAS and then investigate unintentional uses, which is somewhat complex. Where does the PFAS come from? Well, there's accidental PFAS to intentional, and there's sort of a continuum. So accidental use would be contaminated water or ingredients that are accidentally contaminated. PFAS within other ingredients in the supply chain where the purchaser doesn't know about it. Then there are fluorinated chemicals with disguised names. We'll give you some examples. There could be PFAS in the packaging leaching out, and then PFAS intentionally added to help with durability, water resistance, and so forth. So disguised PFAS. Unfortunately, methicone, which is commonly used in cosmetics, can contain PFAS. So it's, but it still can be called methicone. Similarly, acrylate, methacrylate, synthetic mica, all these could contain PFAS. It would not be labeled. And then pigments can sometimes have PFAS. Again, not labeled. So these are words that could, I think, that are in probably most all your cosmetics. And so this is why testing is important. This is, you can't really read this, but Cleria, that is a very useful service that can tell consumers what chemicals of concern are in products that they're buying online at Amazon or Walmart. They compared what was on labels of thousands of cosmetics with known PFAS. And you can see that PTFE was in 357 products and a whole list of PFAS that are were listed. And this list from Cleria you can use to screen your ingredients. And this list is much more complete than the inky list. And if you have these ingredients, obviously you want to work with your supply chain to eliminate them. Testing your products is somewhat complex. You can send your products to an analytic lab. We list some of these labs that do this testing. They don't all do all the tests. If you go to our website, greensciencepolicy.org, on our homepage, there'll be a link to our brand new page just for this call on PFAS and cosmetics, where we talk in more detail about testing. And the first thing is you want to see if there's organic or inorganic fluorine. And then there's a series of other tests to figure out if you do not have PFAS in green, or if you do, in which case you want to look on your supply chain. So if you want to learn more about PFAS, because we think it's really interesting, we have a whole website called PFAS Central, where we share the most interesting news articles about PFAS, scientific articles, policy, PFAS meetings, jobs, everything PFAS. And by far the most popular page is our PFAS-Free page of products where they list on their website that there is no PFAS. We don't test, we just ask manufacturers to list. And this page was at the request of communities that had been drinking PFAS contaminated water, in some cases for decades, and they asked us if we could recommend products without PFAS. You'll see Credo is listed under cosmetics and personal care products. There's also, jackets, outdoor gear, many other things, but we're glad you're listed. We hope that none of you do have some of this unintentional PFAS. It's likely that some of you do, unfortunately, and we hope that you will take action. As I said, you can go to greensciencepolicy.org, PFAS and cosmetics, or just to our homepage. I think Lydia has put in the link in the chat. And we are happy to have a follow-up call. Those of you who might be interested in talking with us about how you can find and remove PFAS from your cosmetics. If you'd like to join us, you can email Lydia at greensciencepolicy.org or sign up to to the link in the chat. We don't have all the answers, but working together with you and other scientists, we're optimistic that your brands, and we hope eventually all brands, can maintain your function, your value, and be free of this class of harmful chemicals. So I'll just end by saying with reduced use of PFAS, we can have healthier products and a healthier planet. Thank you.